All right, now, if we want to find the p-value, we're going to use this right-tailed test. So it always goes 0 to infinity. I'm going to go in my calculator under distributions, just like we found all the other ones, and you're going to find chi-squared CDF. So it's going to be whatever your formula answer was to infinity. Degrees of freedom are going to be 3. There's 4 grades. All right, 4 grades minus 1 is going to get us our 3, and that's my p-value. Everything else is the same, right? P-value is going to be less than alpha. We reject the null hypothesis, which means that we can conclude that at least one proportion differs from what the advisor claimed. All right. So then if we look at the next problem, this one's saying, did the ages in America change? So this was 1980. In 1980, there were 41% of Americans were this age bracket, 28% were in this age bracket, 20% here, 11% here. So these are our expected percents, because then we said, all right, in a sample of 500 residents in 1996, these are my observed counts, all right? And I want to see, is the distribution the same? Is 1980 the same as 1996? Or are they not the same? Okay, so the percents aren't going to match. So I've got my hypotheses. You can read through those. I did my assumptions, stated to be a sample, random sample. Population of U.S. residents, yep, absolutely. Expected counts are at least 5. I wrote down my expected counts here. All right, these are not quite as pretty. I do the table because it helps me get organized. So I have my ages, my observed counts, figure out my total. So then when I come back up here, 0 to 24 years old, we're 41.39%. So I have my 500 total and my I'm off the screen. My 500 total and my 0.4139 for this percent, so that I get 207. It's fine that you have decimals. I know you can't have a decimal of a person, but we leave these as decimals. All right. So you'll see I plugged them in as the decimals. Okay. This says 101. You can't read it. I threw this in my calculator. We kind of already know that this is going to be a reject because these are really far apart. We expected 107. We observed 177 and we expected 207. That's really different. All right. This is pretty close, but this is really different. And so when the further apart these get, the bigger this number gets. The bigger your chi-squared is, the smaller your p-value is. And then that means you reject. Okay, because it's less than alpha. So if you go back to the original problem, the first problem, all right, this was really different. Like 51 and 40. Out of a total of 100, this is 11 different. This was 14 different, which is why this answer got so big, which is why my p-value got so small.